Morning, everybody. Mr. Stewart here, and welcome to this screencast on independent versus dependent events. So your main objective in this lesson is to apply tree diagrams to solving problems that involve, we've got a bit of a typo here, independent or dependent events. All right, so let's have a look here and see what we are going to do. So all of these notes are posted online. Okay, but I would encourage you to go through this lesson and or using the blank template to think about things prior to checking in on solutions. So in the previous section, if we can call it that, we were looking at combined outcomes. Okay, so I'm just going to highlight and do some underlining here. So some combined outcomes in a sequence of experiments. So in those cases, we noted that there may have been some conditions or a condition that needed to be met. So that given that one event transpired first, that could have had an effect on the outcome of the second. So one way that we can sort of show a sequence of experiments, and you've done this a little bit already, is to use a tree diagram. Okay, so it says here that the successive branches in the diagram correspond to a sequence of outcomes. So as per homework or assignment problem, which you just finished, in fact, 3 coins being tossed, you all went ahead and in question 1 designed a tree diagram to determine the total number of possible outcomes. Okay, but for today, what we're going to do is examine an example where we have 2 balls drawn out of a box or bag in succession. Okay, and the key phrase here, okay, pay attention to this here, is that it's without replacement, okay, from the box containing 3 blue and 2 white. So our question, okay, what's really important here is this is what we want to determine, is what is the probability of drawing a white ball on the second draw? Okay, so that is where we need to begin this. Okay, so let's start a tree diagram. Okay, so what we'll do is let's start itemizing something here. So I'm going to label this as first draw. Okay, so this will be the first event, if you will. Okay, so the first draw. And of that first draw, I'm just going to start drawing a tree diagram. So there will be 2 options, okay, on that first particular draw. So what I'm going to do is I'm going to refer to these as, okay, 2 possible outcomes is that it could be blue, right, on the first draw, or it could be white on the first draw. Okay, so these are 2 possible outcomes, so blue and white, where 1 is simply specifying which particular event is occurring, and that is the first one. Okay, and it might be worthwhile noting that each of these has a specific probability. Okay, so if you notice that the sample space, we have 3 and 2, so at this point in time, n of s is 5. The w, or that is of white, is going to be 2, and n of b is going to be equal to 3. Okay, so 3 elements. So what that means for us is that upon the first draw, we have a possibility, that is a probability, that blue comes first, that is 3/5. Okay, so the probability of B1 would be 3/5. And I'm limited here without drawing, without my pen, to represent my fraction that way. So what I would encourage you to do is that if that's the case for you, is to represent it vertically as opposed to using the backslash. Okay, so probability of B1 is 3/5. So you could actually label this branch with that probability. Okay, but for now I'll just leave it over here. And of course, just going to copy and paste that. Okay, so the probability of white being first, just revise this, would be 2/5. So let's move forward. Let's grow this tree a little bit more so that we can use it to answer the problem. So step number 2, or part or piece number 2 to the solution. Okay, if you read through with me here, here we are assigning particular probabilities to the branches. So you can see that the 2/5 here is being assigned to branch white 1. Okay, and you can see it here. If we continue reading along here, okay, if we focus on notation, take a look at this. Okay, so this particular branch, okay, is going to appear in the second event. Okay, reason being is that I'm denoting 2 as the second event. So this reads the probability of the second one being white given that the first is white. Okay, down here you can kind of see the notation is that the probability is 1/4. Okay, now let's have a look through the diagram as to why that's the case. So we're going to expand this out a little bit, bring this into view, and let's have a look at all the branches. In fact, let's look at a piece at a time. So let's go off of the top one. Okay, so what you can see here is that upon the first one being drawn as blue, we have 2 options. Okay, the second one could be blue or the second one could be white, but that is under the condition, right? This part's really key here. This is, let me see if I can draw a shape around this just to emphasize that. I don't have a lot of options in terms of shapes, but let's do it this way. Notice this piece here, in fact here, okay? And let's expand upon that. It's really the symbol I want you to take note of, and that is this, is that vertical bar, meaning given that or such that. So it's important to see that it is this the notation specifying what comes first. So drawing blue on the first draw. So what that means is that the probability of getting this outcome, right? Blue 1 and blue 2. Okay, we'll figure that out later. But in terms of blue 2, given that blue 1 has occurred, we now have a 1/2 chance. Okay, because the sample space has been reduced to 4 balls left in the bag or box, and of course only 2 of those, okay, remain to be blue. Same thing with the white. Okay, 4 balls left in the sample space, 2 of which would remain as being white. Okay, so let's move forward with the rest of the diagram. So you can see here, okay, that the remaining outcomes, if you look at this here, the remaining outcomes, here we have white being drawn on the second, given the first is white. So once again, the sample space is reduced to 4 elements, okay, but only 1 of which can be white, right, given that there are 2 to begin with. And down here, drawing white first, the second one being blue, sample space again reduced to 4 elements, of which there are still 3 blue remaining as white was drawn first. Okay, so let's have a look at the goal. What are we looking for? Okay, so I want to go back to the main problem, and the question is white on the second draw. What is the probability of white on the second draw? So at this point in time, we've extended our tree diagram enough to cover 2 events, and what we're looking for is white on the second draw. Okay, so that would mean white on second draw occurs here, and white on the second draw occurs here. Okay, so we are concerned with these events here. Okay, what is the probability of blue on 1 and white on 2, and then white on 1 and white on 2? Okay, so this is what we need to focus our attention on. So growing the diagram, adding more notation to it within your own notes, here are our probabilities. Okay, so if you follow through using the probability of independent events, and remember that the probability of independent events, okay, the multiplicative rule, okay, so the probability of A, either the is equal to probability of A that is multiplied by the probability of B, and that was for independent events. Okay. Now, of course, today, under a dependent condition, what we're going to do is we're going to apply the same rule, except the notation changes somewhat. So the probability of A and B, same thing, although the probability of B given A, okay, that's the difference, is that the sample space changes because of the dependency. Okay, so having a look here, you can follow through on the tree diagram to see the relative or important probabilities, and the ones that we were most curious about or concerned with were these two here. So white on 2 given blue on 1, okay, and white being on the second draw. So these are the probabilities that we need to be concerned with. Okay, so I do want to throw in a bit of an operator here. That is a key word. So to come up with the answer, okay, the significance here is that it's drawn on the first, that is white on the second, or white. Let's see here. Blue being drawn first, or white being drawn first. So that word or, that's important. The word or in mathematics, okay, specifies addition. Okay, so through the tree diagram of dependent events, okay, we've multiplied to come to the probability that both events occur. Now the final answer, okay, one or the other, we will end up having to add those probabilities together. So let's move forward here. So in terms of notation, it's always important to practice that. Okay. So the probability of white 2 and white 1, okay, is that of white 1 multiplied by the probability of white on 2, given that white on 1 has occurred. Okay, so that's one particular rule, okay, that we can apply. But that's not the only thing we need to look for. Okay, so as specified earlier on the previous slide, we're not just looking for this, but we're looking for that. And if you go back to the tree diagram, you can see those branches. Okay? So the combined outcome or combined probability, as was noted on the tree diagram, is this. Okay, so in this case, what we'll end up with is the following. So if I can write this out using my stylus, let's see if I'll be okay with that. So white on 1 and white on 2, that corresponds to probability of 1/10. Okay, so let's go back and write that in. So 1 on 10, into that we'll be adding 3/10. That was the probability of drawing blue first and white second. So combining that gives us 2/5 as a probability. Just want to double check I carried forward with the correct fraction. And yes, we're good to go. Okay, so in a nutshell, I guess you could say that is the way that you can process these types of questions in setting up your tree diagram. Do practice the notation. That is important for excellent communication, not just the numbers, but do practice your notation. Okay, so let's see here moving forward. There is another problem here that I'd like you to try, okay, just for an example. And then what we'll do is, based on your work with this and my assessment of where you are coming into this, I'd like to set up a problem-based situation for you to work with your peers at the whiteboards. But for now, what you can do is pause the video and start designing a tree diagram for this one. Okay, and then when you come back into the video, what I'll do is I'll post a student solution that has been drawn up, and then you can check your work against that. Okay. So now that you've given it a try, what I would ask you to do is just take a look at this sample. Okay, this is some student work that I've captured, and what you can see, bring it into full screen, is that they have identified the various paths, okay, using a tree diagram. They have assigned percentages, okay, or the percentages, which is in fact, the probabilities to each of the particular events. So the event going from A to B, and for example, the event of B shipping 30% of its manufacturing off to company E. You can see here at the end, what they're doing is they're labeling the particular defect rate from each of the companies. Over here, use of notation, they're labeling the combined outcome, okay, using proper notation. And then over here, what they're doing is they're listing their probabilities, okay. You can see that they made an error here, that we had corrected that, okay, through the multiplication of the relevant percentages, converting back to percentages here, okay, where necessary. And then down here again, probability of being defective, they're bringing in the notation so you can see how they're taking the combined events, the probability thereof, and using addition, okay, because it's either this or that probability or this one, okay, in terms of deriving an answer. Okay, so that concludes the video. What will happen next is, aside from the assessment on Edpuzzle, what you'll be up against again is tomorrow running through some questions with your peers and leading off with one in particular. Won't share that now. We'll let that be a surprise.